SQA Advanced Higher Maths 2017, number 17. The composite number, the complex number z equals 2 plus I is a root of the polynomial equation z to the 4 minus 6z cubed plus 16z squared minus 22z plus q equals 0. State a second root of the equation for part A. That's just for 1 mark. Z is equal to 2 plus I is a root. 2 plus I is a root. Implies that the conjugate Z equals 2 minus I is also a root. That's all you need for part A. For part B, find the value of k and the remaining roots. This is for 6 marks for part B. Part B, you're talking about maybe 9-10 minutes. So you need to rewrite this as z minus 2 plus I, because that's one of the roots. The other root is 2 minus I, so z minus 2 minus I. Bringing these together here, so write it as z minus 2 minus I, and z minus 2 minus gives you a plus I. Okay, and then when you multiply this out, this is a difference of 2 squares. So this is going to give you, this is z minus 2 squared, which is z squared, z minus 2 squared minus I squared. This difference of 2 squares. So what you have here is z squared minus 4z plus 4 and minus I squared. I squared is just minus 1. So that gives you plus 1. It gives you z squared minus 4z plus 5. You divide that into the quartic. Z squared minus 4z plus 5 is being divided into the 4-degree polynomial. Z to the 4 minus 6z cubed plus 16 z squared minus 22z plus q. Okay, so to eliminate the z to the 4, you need to multiply by z squared, which gives you z to the 4 minus 4z cubed plus 5z squared. Take this away, that goes away. So this is just going to give you minus 2z cubed and minus 2z cubed, and this is plus 11z squared minus 22z plus q. Now to get rid of this, you need to multiply the z squared by minus 2z. So this would give you minus 2z cubed plus 8z squared minus 10z plus minus 10z. That's there. And when you take that away, what do you get? 2z cubed goes away. 11z squared minus 8z squared gives you 3z squared. Minus 22z plus 10z gives you minus 12z plus q. And now you need to multiply this by 3, so you can get rid of the 3z squared plus 3. So that gives you 3z squared minus 12z plus 15 plus 15 what you're left with is q minus 15, and that is equal to 0, which implies that q is 15. So that's your q. The other roots, you need to get the other roots as well. So the other roots come from this and the remaining roots. Okay, so you need to use this z squared minus 2z plus 3. You need to use the quadratic formula. So z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So z is minus b would just give you 2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2. So that means that z is 2 plus or minus the square root of, there's a 4 minus 12, it gives you minus 8 all over 2, which is 2 plus or minus the square root of 2. So you can take a 4 out, so that gives you 2 outside. Inside you still got 2i squared, which is the minus 2 bit. So what you have there is, that means that z is equal to 2 plus or minus 2 root 2i all over 2, which is 1 plus or minus root 2i. This is your other two roots. So your roots are now, okay, so there's a part C here, so you can put that into part C. Okay, show the solutions to this z to the 4 minus 6z cubed plus 60z squared minus 22z plus q equals 0 on an Argand diagram. Okay, so your roots are z1 equals 2 plus I, z2 equals 2 minus I, z3 equals 1 plus root 2i, and z4 is equal to 1 minus root 2i. Okay, so you're going to show these on an Argand diagram. This is your real axis, and this is your imaginary axis. Okay, so 2 plus I, this is 1, 2, 1, minus 1, minus 2, 1, 2, minus 1, minus 2, minus 1, minus 2, 1, 2. Okay, so 2i, 2 plus I is going to be around here. So you can either write that as 2 plus I, or you can write it as 2, 1. Okay, so that is z1. Now your z2 is 2 minus I. 2 minus I would be down here. So you can write that as 2 minus I, or you can write it as 2 minus 1. The other two coordinates, 1 plus root 2i, 1 plus root 2i would be above this somewhere here, say. This is 1 plus root 2i, or 1 root 2. And down here you'd have 1 minus root 2i, or 1 minus root 2. So that's your 4 roots on an Argand diagram. This is for, this last bit is just for 1 mark. This is only for 1 mark. Okay, so most of your marks are in B. That's number 17.